Welcome back, Physics 30. This is part 2 of this CO1.3 section. So we just figured out the kinetic energy here of this car that's increasing speed from 20 to 30 meters per second. And as we can see, it asked for work. So if we can see a change in speed happening here, we know that there's a kinetic energy here. And we're going faster, so it's an increase in kinetic energy, which means you must have had an increase in work done on that. Let's look at this example, the last one. Catching a baseball. A baseball, 145 grams, traveling at 32 meters per second, moves a fielder's glove backwards 25 centimeters when the ball is caught and brought to rest. What is the average force exerted by the ball on the glove? Okay, this is similar to the hammer and nail question. So we have a ball moving this way, okay, so a baseball, and here you have a glove. Okay, it's kind of a sad looking glove, but it's going that way. So VI, it's moving 32.0 meters per second, and then when it hits the ball, the glove is going to be going that way. Now 25 centimeters, of course, with all of our displacements, it has to be in meters, so 0.25 meters. And the and the ball is brought to rest. So that's what's going to happen there. It's going to reach zero. So we can see here the ball is going to be losing energy. And if I can figure that out, I can figure out how much energy the glove is gaining, because it was at rest and it's moving back. So if we look at work done on ball, because that's all the information we have, really. We have the ball's mass, we have its initial and final. We know something here, but we don't know enough to finish it. So work is equal to change in energy, and it's kinetic energy. And of course, this is kinetic energy final minus kinetic energy initial. And so that's 1/2 mv final squared minus 1/2 mv initial squared. So the ball, 145 is 0.145 kgs, and it's being brought to rest, right? Because that's the final velocity. The initial velocity of the ball was 32. Okay, so if we work, okay, all this is going to be 0 here. And when I take 32 squared multiplied by 0.145 multiplied by 1/2, I get negative 74.24 joules. Lost by ball. Therefore, glove gains 74.24 joules of energy. Whoops, I guess I should actually move this up so you can see what I'm writing. So over here, the ball lost 74.24 joules. So that's very similar to the hammer. The hammer losing energy as it hits a nail. Therefore, that energy must have been transferred to the glove, and the glove is gaining that energy. Now, we're not told anything here about the glove in terms of speed, but what we are told here, we're asked to find force, right? And force is part of the work equation. So work is equal to force times displacement. You know what? I could throw cos of theta in there as well. And so average force, so I could say the change in kinetic energy is equal to this. So energy lost by ball is equal to energy gained by glove, or I could say all that energy decreased and caused work to be done on the ball. Whichever way I look at it, that is going to be 74.24 in the positive, because if the ball is losing energy, the glove is gaining energy. Or if it lost this much energy, it's doing this much work on the ball. So looking for F, D, we're told that the glove moves back 0.25 meters. And the glove is moving back this way. The force is that way, so it's the cos of 0, and of course we know the cos of 0 is 1. So really what I'm doing here is I'm figuring out F is equal to 74.24 divided by 0.25, because divided by 0.25 divided by 0.25, this part here is going to be 1, so it's not going to change anything, and I get 296.96 newtons. If I round that off to 3 sig figs, 297 newtons. Okay, so that's kind of a tricky question because you're looking at two scenarios here. You're looking at two different objects. One's losing energy, one's gaining. The energy that was lost by one object is equal to the work done on the second object. All right? Okay, so that's it for that section. Now, when you look at the assignment, the last question is kind of like this too. It involves shooting an arrow, an 85 kg arrow, or sorry, no, 85 gram arrow. So 85 grams is equal to 0.0850 kgs. It's fired from a bow which exerts a force of 105 newtons over a distance of 75 centimeters, which of course is 0.75 meter sticks. What is the speed of the arrow as it leaves the bow? So we're looking for V final, and guess what? It started off at 0. So that's the information that we have. So again, work is equal to change in energy. When we're using a bow and arrow, of course, that's going to be kinetic energy that's going to be changing. So 1/2 mv final squared minus 1/2 mv initial squared. So hey, what we know here, we can figure out, if we know F and if we know D, if we know this and we know this, we can figure out W. And then once we know work, that's really the energy involved. We know the mass. We know the initial velocity. So we just solve for VF. So it's a little bit easier. There's not a, we're transferring the energy over. Nothing's losing. So that kind of gives you the setup for that assignment. So you can take a look at that and hopefully that helps you out. Okay, so you should be able to do the CO 1.3 assignment. We'll see you again.